Okay, we are wrapping up the week, October 22nd. I will add to solve a problem and I will count objects. I will add fractions to solve a math problem and I will count functional objects. I will identify how objects moved and describe scale drawings. We're going to do this one first, doesn't really matter which order, but I'm going to focus on this one first so we can talk about the movements and shapes because the other is a little bit more of a review. So let's do this first and then I can help you review for the rest. A little bit more geometry for us. We are talking about transformation, so how shapes move. All right, so remember one, the translation or the slide. We called it a slide. It's easier for us to kind of remember. Remember this picture of an ice skater. They are just, the shape is simply slid to another spot, okay? So it can slide left, right, up, down, or diagonally. So anywhere it goes, if it doesn't move, all these coordinates stay the same, right, in the same distance from each other, and it just slides, okay? Remember, it can slide over all these different ways, but the shape does not change. A reflection. Remember, a reflection is if it flips. So think of it flipping over to the other page of a book, okay? Pretend that this is where it folds in half and it flips from one side to the other. It's a mirror. And then a rotation or a turn. Remember this example right here of the flag on a mailbox. The flag is exactly the same, but it's moved from down to up. So this spot right here, it rotates on the same point. So this point does not move. So see on here, the shape was here, just like it was on these. It was here, and this point stayed the same. The rest of the triangle moved. So when it's rotating or turning, one spot remains the same. Sorry, I'm going to go forward because I know that when we did these were a little bit more helpful at the end first. So Keisha puts a right triangle on a grid. So remember, we know it's a right triangle because this is 90 degrees. She moves it. How does she move it? Remember what this arrow means. What did she do? Did she slide it, flip it, or turn it? Right? She didn't slide it because the shape is different, right? The shape is still a triangle, but it doesn't look exactly the same. She didn't turn it because none of these are the same point. It moved, so it flipped.
Flips.
Right? How about this one? Where did it go? How did it get from one place to another? What did he do to the square? It could be two different ones, right? We think that like it could be flipped because it's a square, but this arrow really helps us. Remember, if it's a flip, it uses this curved arrow. Okay, but if it's a slide, it uses the straight arrow.
Slides.
Okay. Okay, our second activity with shapes is talking about scale. So remember, transformation is when it's moved from one place to another, and then scale is when it changes size. So the scooter board, what happened to this? Here's the scooter board, here is the copy. What happened to it? The copy is either the same, bigger, or smaller. So we're going to decide that this copy is smaller. Oops, why couldn't I do it? Smaller.
Smaller.
There we go. Yours also might look like this. We are going to, when you complete this, make sure you're just reading every part of the question, okay? Right, follow the directions. Write the length of the blue side of the scooter board picture on the chart. So here's the blue side. Scooter board picture on the blue side is 12.
12.
And it says, do you need to divide or multiply? It told us that
Divided by.
It told us we needed to divide it, and that's the reason why is because it's smaller. So it reminds us right here, is the copy smaller or bigger than the scooter board picture? If it's smaller, we divide. If it's bigger, we multiply. Okay, so yours might not have that clue if yours looks like this, but same thing. It tells you what to do and just doesn't give you the answer here. Okay, so just think, if the copy is smaller, you divide. If the copy is larger, you multiply. So just a few notes for the rest of your assignments today. You have 2 addition assignments, and I just want to make sure that you're doing them by following the directions, okay? I know that you know some of the answers and they come to you fairly easily, but I need you to do the work. Otherwise, it's not showing on my end that you're completing the work correctly. So it says use the space below to draw the problem. So number of volleyballs that Raj puts away, 5. 1, 2, 3, 4, 5, right? How many does Keisha put away? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the program wants you to do this so that we know that you understand. Okay, how many do they put away altogether? Altogether means we're adding, we're counting on. We're going to start with 8, 9, 10, 11, 12, 13. Okay. Same thing here. Please use these so that you can use the problem so that I know what you are doing. Otherwise, it's not going to say that you completed your work. And then that's a bummer. One last thing I want to show you. I know that when you're adding 3 numbers, it doesn't have the space to do the work underneath, and that's totally fine. Remember to start with the ones place first. So you're adding the 5 plus 1 first, and then you're adding 2 plus 1 plus 1, and that goes over here, okay? And then on the very last page, you're going to see this up here. And so if you feel like you need some more practice, or if a teacher says, hey, can you do that again? Show me that show me that you can do that. Just push this button and it will give you different numbers. Okay, so now it says 20 plus 20 plus 8. If you do this, it'll give you a new one. Okay, so just good practice for you. All right, nice job.